Alfred here. We're going to solve two problems today. The first is a house with an R1 zone, and the second is another house but on an R2 zone. Solving these two problems need two different approaches, and we will show them to you. We will also discuss all the important references you need to consider when finding the building height limit, the maximum percentage of site occupancy for finding the total gross floor area, floor to lot area ratio, converting gross floor area to total gross floor area, setbacks, total open space within a lot, impervious surface area, unpaved surface area, and more. We also made a list at the end of the video about the things you should always remember when solving design problems. The reason why we put the R1 and R2 problem on one video is that we want to show you their differences. After the solutions are shown, we will visualize each answer till you'll have a clear understanding of solving the problems. Alrighty, let's start. A contemporary house will be built on a lot with a frontage of 18 meters and a depth of 35 meters. The client has an inside lot classified as R1 zone sloping 12% towards the street with a 14-meter wide road with a 1.2-meter wide sidewalk and 0.80-meter wide planting strip side to side. Determine the allowable maximum building footprint, percentage of site occupancy, unpaved surface area, impervious surface area, and the total open space within the area. Some problems do include information that you don't have to use in solving it. Point which are the relevant ones and use them. The givens are: frontage equals 18 meters, depth equals 35 meters, width of street equals 14 meters. The unknowns are clearly stated on the problem. These are the variables we need to find. Before we start solving the problem, let's first take a look at the table references we need from Rules 7 and 8 and learn this from a general point of view so that when we go back on the problem, we have a macro understanding of how to use the Rules 7 and 8 to find the values we need. Let's first start with the tables on Rule 7. You can use Table 7.1 to find the building height limit, the maximum percentage of site occupancy when finding for the total gross floor area. You may also use the Table 7.2 to look for the value of the building height limit. Table 7G.1 is used to find the floor to lot area ratio, while you can use the values on Table 7G.2 when converting gross floor area to total gross floor area. Now let's switch to Rule 8. You'll need to refer to Table 8.1 if you need to determine the values of total open space within a lot, impervious surface area, unpaved surface area, areas ND maximum percentage of site occupancy. You can use Tables 8.2 and 8.3 to find the required setbacks for the problem. We will dissect each table later when solving the problem and referring to the specific tables we need. Each zones requires us to refer to different parts of the tables, and we have prepared examples to cover them. Let's work out the simpler unknowns first. We'll start by finding the total lot area because we will use it on our further computations. Finding the allowable maximum building footprint is straightforward for R1. We only need to eliminate the combined areas of the setbacks, and we're good to go. On R2, we will use a different approach to this. Now, we'll use the value we got and divide it by the total lot area. We need to express the percentage of site occupancy into a percentage, so we'll have to multiply 100% to the equation. We have 63.33%. In R1, we can consider the unpaved surface area as the yard 1, which is the front setback in this case. If you encountered a problem that requires an answer expressed in percentage, then multiply your answer by 100%. The impervious surface area for R1 oftentimes refers to the side yards and rear yard. By adding their values, we got a total of 150 meters. Multiply the value by 100% to express the answer in percent. Now I think you know how to compute the total open space within a lot. Add the front, sides, and rear yards, and you'll get 231 meters. As you watched in our previous video entitled How to Solve Design and Planning Problems, Introduction, one of our tips to be a great problem solver is to gut check or double check your answer. For this problem, we could use a different formula for T, O, S, L to verify our answers. We can subtract the total lot area to the allowable maximum building footprint. Cool. It's a match. We advised you to always be playful on verifying your answers by using different equations. By doing this, you'll have more confidence and peace of mind on passing your exams. Before we move on to problem number 2, let's have a quick visualization of the answer so you'll understand the computations graphically. Now let's jump into the R2 problem. A 3-story residential house is scheduled to be built on a corner lot on an R2 zone. The frontage faces south with a dimension of 28 meters and a depth of 18 meters. 14.4-meter wide roads are connected to the west and south sides of the lot. The client will be the landlady of the new residential house, and she wants to know what will be the sum of all the floor area of the house that she can generate revenue. Let's analyze the given information and pinpoint which ones are useful for solving the unknowns. The useful values given are: frontage equals 28 meters, depth equals 18 meters, width of street equals 14.4 meters. You might have noticed that the things we need to solve this second problem are not as straightforward as the first problem. In this case, we need to use our understanding of the equations and terminologies we are using. According to the problem, we have to find the sum of all the floor areas and open space left. I'll give you 5 seconds to pause this video and think about the formulas we need. You could refer to this list. Alrighty. We will use the equations about total lot area, allowable maximum building footprint, percentage of site occupancy, total open space within lot, total gross floor area, and we also need to refer to the building height limit. Okay, let's start computing. We should first put the setbacks required. Since the lot is in an R2 zone, we need to follow these setbacks. In the first 3 equations, I stated, we will repeat the method we used on the first problem. Multiply the lot width and length to get the total lot area. We got 504 square meters. Exclude the total area created by the setback to get the allowable maximum building footprint. We have 299 square meters. For the percentage of site occupancy, we only have to divide 299 with the total lot area and multiply it to 100% to express the answer in percentage. You round it off, and we got 59%. Now here is the part where R2 zones differ from R1 zones. As you remember on problem 1, we got the answers for unpaved and impervious surface areas by getting the areas of yards 1, 2, 3 and 4. For R2, we have to refer to a specific table 8.1. First, locate the zone of the lot we have. You might have noticed that there are letters E and F after each number in the third column. The letter E stands for with easement, and the letter F stands for with a firewall. In our case, we will choose the values that align with R2 with the number that has the letter E. We will get 30% for I, S, A, and 15% for U, S, A. Get the 30 and 15% of the total lot area and add them. We got 226.80 square meters. Since we're aware that the house will be 3 stories, we now only have to verify if it's allowed per table 7.2. There are no stated whether we need to refer to the maximum, so we will choose the base option, which the basic. At last, we're on the finale. This part is where tables 7.1 and 7.2 will come handy. We know that the project will be 3 stories. We need to figure out the percentage we can use as a multiplier for the total lot area. According to table 7.1, we need to use 70%. This equation will give us an answer of 1058.40 square meters. Now we know that the sum of all the allowable floor areas per the code is 1058.40 square meters and the total area of the open space left will be the of I, S, A, which is 151.2 square meters. Let's have a quick visualization of the answer so you'll understand the computations graphically. We will produce more design and planning computation videos soon. This is the first video we made for the series. Smash the like button and click subscribe to help us expand and help more architecture and design professionals like you. We also offer free software tutorials. Sign up to www.architectureshare.com and put your name and email to get notified. You can watch our previous videos about computations too. We are incredibly motivated to teach more design professionals, and we hope to see you in our future videos.